In this lesson, we're going to continue rationalizing denominators, but the denominators are going to look a little different. I can give you a preview of that. They have two terms. Now, how are we going to rationalize a denominator that has two terms? In order to understand how we're going to rationalize these denominators, I want to remind you of a certain kind of product you had back when you were studying polynomials. It was called a sum and difference product. And suppose you had x plus 2 times x minus 2. The product of the first is x squared. It turned out that the outer and the inner were opposites every single time you did a sum and a difference of the same two terms, so you could skip the outers and inners. And the product of the last is minus 4. You get the difference of two squares. We're going to use that. Let's suppose that we multiply the square root of 2 plus the square root of 3 times the square root of 2 minus the square root of 3. Sum, difference of the same quantities. The square root of 2 times the square root of 2, please remember, square root of 2 times itself, the radicand pops out, and that's equal to 2. The outer product and the inner product, the outer will be negative square root of 6, the inner will be positive square root of 6, but we don't have to worry about that. They're going to cancel when it's a sum and difference product. The square root of the product of the last is negative times positive times negative. Square root of 3 times square root of 3 is the square root of 9, which is 3. You get the first one squared minus the second one squared. Those will be rational numbers. Do that subtraction and you get negative 1. So when you multiply these, you get a rational number. When you have radical expressions like this, 1 plus of those quantities, 1 minus of the same quantities, those are called conjugates. That's a good vocabulary word to remember as we finish this unit and when you take your college algebra class. So, when you're asked to rationalize a denominator that has two terms, you're going to use the conjugate of the denominator. The conjugate will be 2 plus the square root of 7. And we put it over itself because that makes the number 1. What do I get? In the numerator, I'm going to use the distributive property. 6 times 2 is 12. 6 times the square root of 7 is 6 times the square root of 7. The denominator. These are conjugates. The product of the first, these are not radicals. That's just 2 times 2, which is 4. Outer, inner, we get to skip. Product of the last. It's going to be minus negative square root of 7, positive square root of 7. Well, the square root of 7 times the square root of 7 is 7. Please be very aware of when you're multiplying rational numbers. 2 times 2 is 4. The square root of 7 times the square root of 7 is the square root of 49, which is rational 7. All right, this gives me 12 plus 6 times the square root of 7 all over negative 3. You want to look and see if this rational number, and this rational coefficient can be reduced. And you can. You can divide negative 3 into each one of them. That's going to give us negative 4 minus 2 times the square root of 7. And that's our answer. So only if all three of those rational positions can be divided, and I divided negative 3 into that one, negative 3 into that one, and when I divided negative 3 into that, the denominator became 1, and I didn't write the denominator. So let's take a look at number 2. When you have a radical and another term in the bottom, to rationalize that, you're going to use the conjugate, which in this case is 1 plus the square root of 3. 1 plus the square root of 3. Because this is a rational number, I'm just going to use the distributive property. 4 times 1 is 4. 4 times the square root of 3 is indeed 4 times the square root of 3. Over the product of the first, 1 times 1 is 1. Outer, inner, we don't worry about it. Product of the last, it's going to be negative because I have a negative times a positive. Square root of 3 times square root of 3 is 3. So I have 4 plus 4 times the square root of 3 all over, in this case, negative 2. I rationalized, made a rational number out of the denominator. Can I either divide negative 2 into those or reduce the fraction? The answer is yes. Negative 2 goes into 4 negative 2 times. Negative 2 goes into 4, negative 2, but there is the square root of 3. The denominator is now 1. Okay, let's look at number 3. I'm going to multiply by 1 minus the square root of 3. Sorry, 6. 1 minus the square root of 6, because that's the conjugate of the denominator. The numerator, that gives me 2 times 1 is 2. 2 times the negative square root of 6 is indeed negative 2 times the square root of 6. On the bottom, 1 times 1 is 1. Outer, inner, can't forget about those. Square root of 6 times negative square root of 6 is negative 6. That gives me 2 minus 2 times the square root of 6 all over negative 5. You can write it like that. You could put the negative out in front of the fraction. I would just leave it like that. No reducing this time because these numbers do not share a common factor. All right, let's look at one more. I'm going to multiply by 1 minus the square root of 10. 1 minus the square root of 10. On top, that gives me 8 minus 8 times the square root of 10. And on the bottom, these are conjugates. I have 1 minus square root of 10 times square root of 10 is 10. That gives me 8 minus 8 times the square root of 10 over negative 9. I want to give you one example because there's not one, but I want you to see it for what happens in the future. What if you had 3 plus the square root of 5 over the square root of 2 minus the square root of 3? That's slightly more complicated. The process is the same. You're going to multiply by the conjugate of the denominator. And even now I have 2 radicals. The conjugate is still the plus version. The real difference is in the top here. You've got 2 terms times 2 terms. I need to use FOIL. In all of my examples, I use the distributive property. If I use FOIL on the top, those are not conjugates, so I have to do all the terms. 3 times the square root of 2 is the first. The outer is 3 times the square root of 3. The inner is the square root of 5 times the square root of 2, which is the square root of 10. The last is square root of 5 times square root of 3, which is the square root of 15. And there are no like radicals up there. The denominator, those are conjugates. Square root of 2 times square root of 2 is 2. Outers and inners will cancel. Negative square root of 3 times positive square root of 3 gives me negative 3. That denominator is negative 1. So this would be, I'm going to divide negative 1 into all those. It's going to change them to negative 3 square root of 2 minus 3 square root of 3 minus square root of 10 minus square root of 15. I didn't do anything new in that problem that I just made up, but it was a little bit more extensive than the ones that are in your exercises. And I wanted you to see it because you might see it in the future. Okay, time to do your homework.